section 2.5, similar figures. Simply put, similar figures are figures that have the same shape but not necessarily the same size. And here you go, I've given you a little picture of it. I have two triangles. They are the same shape, but of course they are not the same size, and that means that they are similar. And the way we write that is we would say triangle ABC, and this symbol right here means similar. So triangular ABC is similar to triangle DEF. And the way we know when two figures are similar are a couple of things. It says that the corresponding angles are congruent. So notice this, A is congruent to D, B is congruent with E, and C is congruent with F. And I've got that written down here. And actually, yeah, I just mixed that up. So let's change that just to be consistent. This would be C and this would be F. So that's the first part. We know that those are congruent and they are the same angle. And the next piece is that the corresponding side lengths are proportional. And I'm giving you kind of more of an equation here, and I'm going to show this in numbers. It makes it a little bit more easier. But basically, the proportion between this side and this side will be the same thing as this side and this side and this side and this side. And I'll show you that a little bit more with numbers, and it makes more sense. But this is the basic rule. So let's just get on into it. It says, tell whether the two figures are similar. Explain your reasoning. So one, we need to look at angles. Well, it's kind of hard. We know that this is a 90-degree angle, and just by looking at it, it looks like these two angles are the same, so it's possible. But let's look at that second part about knowing whether things are similar, about the side lengths are proportional, all right? So just by looking at this picture, it looks like these two sides are proportional, so I'm going to kind of write it 20 over 4. This 20 is proportional to this 4, and we're going to put an equal sign. And then since these two are my hypotenuse, I'm going to do the same thing, 25 over 5. And then lastly, I'm going to do the same thing with these two. Now, if this is indeed similar, when I go to simplify this, all three of these should say the same thing. So 20 divided by 4 is 5. 25 divided by 5 is 5. And 15 divided by 3 is also 5. All of these are literally the same number. Therefore, we can say that these two are indeed similar. So we're going to do the same thing with this one. We know we have a 12, and we're assuming that this 8 is going to go with it. All right. So we could say that 12 over 8 is equal to this 9 compared to that 5. 9 over 5. And we're going to see if they are similar or not. So if I go ahead and plug this into my calculator, I can say 12 divided by 8 gives me a weird thing, 1.5. So that's cool. And then I can do the same thing, 9 divided by 5, and I get 1.8. So because these things are not the same number, the answer to this would be no, they are not similar. All right, let's move on to number 3. In your classroom, a dry eraser board is 8 foot long by 4 foot wide. So I have an 8 foot long and 4 foot wide. Okay. So I've got that little board. And then it says the teacher makes individual boards for you to use at your desk that are 11.5 inches long. So I'm just going to draw another shape here. 11.5 inches long and 9.5 inches wide. Are the boards similar? Well, your first instinct might be to go ahead and just put these two together and say 8 over 11.5. But here's the problem with that. This measurement is in feet. This measurement is in inches. We cannot do that. We need to put them in the same unit of measurement. So the easiest one to do, actually, is I can either convert this into feet or I can convert this into inches. And the easiest one to do is to put this into inches because I don't have to worry about getting some weird numbers and stuff like that. So, how do I put feet in inches? Well, recall back, there are 12 inches to a foot. So I can say, since I know that there's 8 feet and there's 12 inches per foot, I can say that this is technically 96 inches. I'll cross that out so I don't get confused. And then I can do the same thing. 4 feet at 12 inches per foot gives me 48 inches. Now that I have that, I can actually set up my proportion and my ratio. So I know that this and these two go together because this is going to be 96 long and this is going to be 11.5 long. So I'm going to say 96 over 11.5 is equal to 48 over 9.5. Now let's see if that works. 96 divided by 11.5, I think, yep, cool. And I get some weird number. Ugh, I don't like that. Well, don't forget, you do have a button that can change this into a fraction for us. So we're going to hit second PBR to get that fraction to decimal, and it gives me a nicer looking number. So I could say 8 and 8 23rds, excuse me. So let's find out about this one. 48 divided by 9.5. I get some weird number again, and I'm going to do the same thing. I'm going to hit second PRB to find out what my fraction is. And what I get is, can't see it on my screen, is 5 and 1/19. Now, are these indeed proportional? No, they are not, because these two numbers are not the same. So no, these are not proportional. All right, let's look at the next one. You have a 4x6 photo of you and your friend. You order a 5x7 print of the photo. Is the new photo similar to the original? So let's do it again. We have a 4x6 and we make a 5x7. All right, so let's set up a proportion. We know that these two are going to go together, so we'll say 4 over 5 is equal to 6 over 7. Because we're setting up a proportion. And let's see if it works. 4 divided by 5 gives me 0.8. 6 divided by 7 gives me 0.85, blah, 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 blah. Or, again, if we were to change, so that's the closest decimal, but just looking at it right now, I'm not even going to worry about changing this into a fraction because technically it already is, but that's another story. So 8.57, blah, 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 blah. Therefore, these two things are no. They are not the same. They are not proportional to one another. Therefore, they are not similar. So, then it says you enlarge the original photo to 3 times its size on your computer. Is the new photo similar to the original? So the original photo was a 4x6, okay? And it says that you blow it up or you enlarge it 3 times. That means that you're going to take this and multiply it by 3 to get a larger length. So that would make that as a 12. And you're going to do the same thing here, multiply it by 3, and you would get 18. Now that you have these new dimensions, you can set your proportions. 4 to 12 is equal to 6 over 18. Let's see if these proportions are exactly the same thing. 4 divided by 12 gives me 0.33333333, and you better know that fraction to be 1/3. And 6 divided by 18 gives me 0.333333, and you better know that fraction is 1/3. And since both of these things are the exact same number, that means that yes, this is a proportionate to one another. Yes, these are similar. So this is pretty straightforward again, just like most of the other stuff that we've done in this chapter. As always, you know how to find me, ask questions, and I'll see you in the next video. Bye-bye.